Good day, learners! This is Marilas P. Prudenciano. Today, we're going to investigate the relationship between volume and pressure of a gas, which is called the Boyles law. Boyles law states that the volume of a given mass of gas varies inversely with the pressure when the temperature is kept constant. The inverse relationship is described in this way. If one variable increases in value, the other variable decreases. Boyle's law was formulated by the famous scientist Robert Boyle in 1662. This law relates the expansion and compression of a gas at constant temperature. In his experiment, a J-shaped tube with a shorter end closed and the long end open. He put mercury on the tube and determined the volume of the trapped gas. When he poured some more mercury, he found out that the volume of trapped gas decreases, while the change in height in the mercury increases. Having all the data, he found out that the volume and pressure follows this graph, that the volume of the gas decreases as the pressure exerted on it increases, or vice versa. Boyle's law can be expressed mathematically as pressure is inversely proportional to volume. These relations can also be expressed as the product of pressure and volume equals constant. If the same gas is brought into two different pressures, it will give two different volumes. Then the equation will become P1 V1 is equal to P2 V2. Consider this sample problem. First, we have to identify the given. So we have. Now, we're going to find the final volume. We substitute this formula. Solving for the final volume, we have 20 liters. We notice here that the final pressure decreases, so the final volume increases. It was doubled. Okay, here is another problem. A 2.75 liter sample of a gas is collected at a pressure of 1.25 atmosphere. Calculate the pressure needed to reduce the volume of the gas to 1.5 liters. The temperature remains constant. So again, we have to identify the given data. We have V1 equals 2.75 liters, P1 equals 1.25 atmosphere, P2 is unknown, V2 equals 1.5 liters. The formula is P1 V1 equals P2 V2. Solving for the final pressure, we have 2.29 atmosphere. What can you notice on the final pressure and the final volume? The final pressure increases while the final volume decreases. Okay, learners? Can you follow? Now, we're going to investigate the effect of pressure to the volume of gases by doing this simple activity. The materials needed are the following: plastic bottle with water, balloon, small stone, thread. Under the procedure, get a small stone and put it on the balloon. Inflate the balloon. Tie a knot on the balloon mouth. The weight of the balloon should be balanced. Press the balloon and insert into the mouth of a plastic bottle with water. Fill water to the top. Screw the lid and tight it. Now, what happens to the balloon when you press the bottle? The balloon will shrink as we press the bottle. When you release the pressure on the bottle, what happens to the balloon? As we release pressure on the bottle, the balloon will rise up. What is the relationship between volume and pressure of gases at constant temperature? When a gas is under pressure, it takes up less space. The higher the pressure, the smaller the volume. Okay? Let's try another by doing this simple activity. Everybody, inhale, exhale. Try to breathe in and breathe out and mindfully observe what happens to your lung cavity. Okay, repeat. Inhale, exhale. As you inhale, the lung cavity expands, causing the pressure inside the lungs to decrease and become lower than the outside pressure. As a result, air flows from the higher pressure area, which is outside the body, into the lungs. Exhaling is the opposite process. When the diaphragm contracts as you exhale, it results to a decrease in the lung volume, increasing the pressure inside the chest cavity and causing air to flow out of the lungs. Interestingly, as you inhale and exhale, approximately 500 ml of air gets in and out of your lungs. The activity you have performed enables you to observe Boyle's law, which can be used to describe the relationship between the volume and pressure of gases at constant temperature. Now, where else do you see applications of the relationship between pressure and volume of gases? That is your assignment. Try to discover and make some simple activity involving Boyle's law. Okay? That's all for today. Thank you very much.
So many pieces all back together now. What's your vision?